Hi, so this is Ian, and I'm making this video to show you the little bit of a dust catcher that I put together, which you may have heard of. I'm going to start by displaying an absolutely pristine inside of a shop vac. I cleaned it out, and here's my filter. There's probably a little bit of what have you from before I made this. We'll go ahead and close this up the usual way. This guy is just the tube that came with it. And this is the birdhouse, so to speak. I'll shove that guy in down as far as it goes. This is an extension hose I picked up at Sears. Put it in here. And grab the tool wand. This is going to get loud. Tell you that this is the first time I've done this kind of stress test on the system. So here's the moment of truth. I'll disconnect the power and lift the lid. That's all there is in there. Oh, and you want to look at the filter? There's nothing on it. Where'd it go? There's my fresh fancy new dust collection. So, maybe you'd like to know how it's shaped. Well, take a look in here. Essentially, we have a tangential inlet. I've got a little something in there to block that off so that the air can only go in one side relatively quickly. The inside, well, if you get this angle just right, here, see if you can sort of, it's basically a cylinder with these shaped holes at the bottom. And
the parentheses.
Yes, the parentheses. They're this little block stop doohickey serves an important function of keeping the induced vortex from dipping into the bucket. Otherwise it would probably be quite a bit taller. See, I read in my research that a smaller diameter will separate more dust, and a taller dust collector will also separate more dust. You'll notice there's no cone at the bottom. That turns out not to be all that important. I figure one of two things is happening. Either the cone of the vortex is naturally formed by the air currents as they run up against this and can't get any farther, or something. Maybe we don't have a standard conical vortex. Maybe it's all a cylinder in there. But anyway, it obviously does the job. Let's see, 2 sheets of MDF with some screws. You can't see them because they're covered in dust. Holding the two together. Glue doesn't stick to the so that's part of it. And then, yeah, those were cut out, and then I glued this on. This is just a whole bunch of little bevel-angled strips of MDF. The top is a little weird. Maybe I wouldn't design it the same way the next time around, but what's going on in there is just, you know, kind of circular, the same as I needed a way that I could produce a port for this big hose end.
So would you tell us what MDF stands for?
Oh, that would be medium density fiberboard. It's the same thing those shelves are made of, and it's the same thing as a lot of your Walmart furniture is made of. Last thing, the technical term vortex finder, the size of the inside upward flowing vortex, just big enough for this guy, which is 1.25 inches outside diameter, just a hair under 1 inch on the inside diameter. But the diameter of the inside of the cylinder is about 5.5 inches. Now it turns out that the standard ordinary cyclone design, the inside diameter of the cyclone is only 3 times the size of the vortex diameter. So maybe you're wondering, well, maybe I have some unused space or whatever. I'm not honestly sure what's going on, but as we can pretty clearly see, it works good.
The amount of dust in there you could probably remove with a moist rag real easy.
Now I will say I'm sure glad I'm not breathing that stuff. Alright, so that's it for now. It's Ian signing off.